If few people are waiting already, people are excited to learn from you again.
Thank you.
I'm just quickly checking if the settings are correct for the live stream. Just give me a few seconds.
Okay.
Awesome. Hey everyone, thanks for joining us on Wednesday morning, Tuesday evening, or Wednesday evening if you're joining from the Japan side of the world, the Eastern Asia side of the world. I'm super excited to host Qishen Ha again. I pronounce his name correctly. He had taught me how to say it. Uh, Qishen is coming on the show for the second time, and he is currently ranked as top five. So last time I interviewed him, he was sixth. He's moved up one rank, and he says he'll become one soon. I was asking him when will he become number one. We will be talking about
I'm
his
going
work
to
at.
become number one.
Sorry.
um, it's okay. Go ahead.
No, please say that again, please.
Just go ahead. No
Uh,
problem.
I, I was going to say that I want to learn your secret today of how do you always survive a shakeup. Last time I interviewed you, you had moved up 100 positions. This time you moved up three positions again to the fifth position on the private leaderboard, and also learn about your work. So thank you so much again for joining me on the podcast.
Yeah. Hi everyone. I'm Qishen.
So I want to start by asking you, since the last time we spoke, you've joined H2. What tasks are you working on, and is Kaggle a part of your role? Are you doing competitions at work? How are you balancing both the things?
Yeah. So actually, we grandmaster in H2 are not working. Not mainly working on competitions. We actually building some tools for auto ML on every task, like tabular task or image task or natural language processing task. Every task, and we are going to build auto ML or semi-auto ML tool for them, like driverless AI or hydrogen torch or something like that. So when we are going to build tools like that, we have to confirm whether our tools works good or not. So doing competition is a good way for us to confirm whether our tool is good, it is well built or not. So yeah, so sometimes grandmasters in our team in H2O grandmaster team go for competition, but actually competition is not our work. Yeah.
So last time we spoke, you said you used to stay up all night just to compete on competitions. This time I saw you joined around when it was 1.5 months left for the competition. Did you spend more nights again? Did you spend a lot of time, or how did you balance this time?
Sorry.
So my question is, how did you manage your time for this competition while taking on
Oh,
your responsibilities?
okay. So actually, we are how to say I joined this competition mainly for um, trying to build adding a new task for our tool Hydrogen Torch, which is 3D image segmentation task. So at the same time, we have 3D segmentation competition in Cargo. So that's why I joined this competition. And I was trying my best to build a good 3D convolutional neural network to make make me have a higher ranking in the leaderboard. And after the competition end, I will transfer it into hydrogen torch. So for this point, I just try my best, use my time to improve the performance of my 3D convolutional neural network architecture. But as usual, we cannot just use a single model to win a gold medal in the competition. So I also use some other models, not only 3D models, but some 2.5D. It's kind of like 2D, but it's a little bit different. I will explain it later. Finally, we can have a good result in the competition. So I'm quite confident that what I built, the 3D segmentation neural network, is not bad. Yeah.
If I share my screen again and show everyone how good it is, to say the opposite, if you go to the leaderboard, which I will find in 1 second, I always have so many tabs open, I get lost. You don't have to scroll a lot. On the fifth position, you can find Qishen and Bo, both their team. All data is external. I will also ask about the team name in a few minutes. But as you can see, in segmentation competitions, Chishan was saying there is some shakeup always expected. And for anyone who was a part of this competition, there was a shakeup. As you can see, all teams have moved up or down a lot. But Chishan's team moved up in the leaderboard, which means they built very robust models, and we'll learn about those in a few minutes. But if I go back to the previous point, you were talking about hydrogen torch. Could you share a bit more about what that is and what new models can we expect? Any 3D segmentation models that might come soon to it?
Well, we are going to build ResNet and EfficientNet, the 3D version, for segmentation and classification task for next quarter. And maybe we can see more and more backbone, more and more decoder type in it as well. But I don't know now for now.
Uh, and I will point everyone to the hybrid AI cloud where you can find the hydrogen torch app and great legends like Chishan and Philip Singer and Yahoo and Babakin, to name a few, have all of their ideas in there. So if you want to try that, you can check that out. Um, Coming to this competition,
Yeah.
can you share about why you joined this competition, what caught your interest, and why did you decide to take part?
Well, yeah. Of course, the biggest reason is that at that time we only have one image-related competition, but very luckily it is a 3D segmentation competition, which we are going to. It's what exactly we are going to do in our work for a hydrogen torch. So that's why I joined this competition. I go to the competition and build my 3D CNN models to see whether it works well or not. If it works well, so I can build the 3D image segmentation task for a hydrogen torch very confidently. So well, as a result, actually I do very good in the 3D CNN model. So yeah, I have achieved what I want. So yeah, very luckily.
Uh, Last time also you said it's luck. All of us disagree because last time you moved up 100 positions and you said you were lucky. I don't think so.
Well, maybe sometimes people like to overfit a public leaderboard. I don't know, but I never do
Um,
that.
could you for the audience share why are 3D problems different from regular CNN problems, and how much more of a challenge is it to create 3D models that perform well?
Yeah, actually, the for this competition, the data set was constructed as 2D images as original provided. But we know that it's a 3D task, so we can construct 3D images from those 2D images provided by the host. Well, but for many cases, 2D CM model, all of us know that maybe most of you well know of that and use 2D CM model to do many tasks, classification, segmentation, detection, or something else. But maybe few of you have done 3D tasks. So the biggest difference from 2D to 3D is that the number of parameters in the model is quite larger than 2D. Yeah, so you know that because one dimension it will cause a very large number of hyperparameters. So in this case, we only can use a very few batch size to train the model. So as you know, when we use a smaller batch size to training deep learning model, the batch normalization will not work very well. That's the most challenge thing in 3D image tasks. But typically for classification, I think segmentation is a little bit better than classification when it comes to little batch size, I think. Yeah, but it still is a little bit challenging. We cannot change 3D model very well without like bigger batch size with batch normalization. That's one point. Another point is that everyone knows that when we train 2D models, 2D CN models, we always use some pre-trained weight from ImageNet. We all know that because if we load pre-trained weight from ImageNet, then we just fine-tune it for our task, it will the convergence may be much faster and the performance may be much better than we train from the scratch, because ImageNet it has many images full of divergence. It's very many type of images, animals, cars, shapes, or birds, or something like that. So when we fine-tune it works very well, much better than we train from the scratch. But for 3D, we don't have we don't have something like ImageNet pre-trained weight. So that's another challenge thing. Yeah, that's all.
Thanks for sharing that. Training time also goes from 2 days to 5 days, 7 days if you step into 3D problems from 2D problems.
Yeah.
Um, this is on a different area, but do you always start with ImageNet weights? For example, even if you are working with, let's say, satellite images or very different images, do you prefer to always start with ImageNet weights?
Sorry?
So if you are working on like a different task, let's
Yeah.
say satellite images or even microscopic images, would you always start with ImageNet weights, or have you found like areas where it's not very helpful?
Well, yes. If I'm doing 2D tasks, I always started from ImageNet pre-trained weight. It's always the best answers. Then always a better answer than train from the scratch.
Okay. And coming back to your previous point, you said you shared these small details of why it's harder to make 3D models work. For
Yeah.
someone who is new, who is like maybe this is their first 3D competition, how do we learn these tricks? Because I assume through your experience you have learned these, but these are not really shared in the Kaggle forums as well. Like everyone says, I use this model, this is how it worked. How do we find these little
Okay.
details?
Okay, so the first thing, maybe people should look at the discussion and the public notebook in the competition when you try to start to learn something new for the competition. Like this time, we have many people published 3D model notebook using Monai. Maybe you know that. It's a very famous 3D convolution neural network library, typically for medical images, medical 3D images. So this time we use Monai as well. Yes, this one. It is um, published from NVIDIA, I think, and maybe for now it's the on. Maybe when you want to use 3D segment, you want to use 3D convolutional neural network. This is the only choice for now, but maybe 3 or 4 months later, we will have it in hydrogen torch as well.
Okay. And with that, you can just click a few menus and have everything work nicely with all of Chishan's ideas in there. Um, so once you signed up for this competition, I want to share a different story first. So
Okay.
I actually, me and my team were also participating, and I went to Bo. I asked him, "Hey, I see you on the leaderboard. Can we team up?" He said, "Go away." No, you are a noob. I only team up with Chishan. So
Okay.
how do you decide your teammate? Will you ever team up with anyone apart from your former teammates? Because you always stick to your older teammates, right?
Yeah. So you do you want to team up with me?
That's a selfish question. Yes. What do I need to do to get to that level?
Well, how to say? So when when I joined Kaggle maybe two years ago, I was just doing solos for competition, and after some time, I I got maybe 2 or 3 solo goals, and people start to come to me and ask me, are you willing to team up with me, and kind of like that, um, and how to say, from that time I start team up with people, but I'm not always say okay to everyone, to those who come to me, because I heard something bad, actually something not very good from my friends. Like when you team up with someone else, you don't know very well, and sometimes you just disappeared when you got team up. Maybe some of you, maybe if you have joined cargo competitions, or maybe you have teamed up with someone, maybe some of you might experience it as well. So actually, sometimes we should be very careful when we choose our teammates. Even though someone, after team up with you, he's not going to disappear, but maybe sometimes it's just a sub account. Maybe he has another main account and doing solo, and he used a sub account to join you and copy your solution, and you use for his main account, and he got the solo gold, and you just whatever. So sometimes bad thing happens when you team up with someone you don't know very well. So typically for our grandmaster, so when we choose our teammates, we have to got very well known to that person before we decide to get him join us. Yeah.
So I need 3 solo goals to get your trust. That's what I understood. I need to spend 20 years, get 3 solo goals, and then maybe Chishan will team up with me.
Getting on solo goals is really hard recently because after we know that we have many grandmaster joining competition now. So when people become grandmaster, they are rather than team up. How to say, they like to team up rather than solo when they become grandmaster, because solo is quite a hard work. We have to do everything for a competition by ourselves. That's like exploring data and designing model, doing every experiment by ourselves, and logging every result, analyze every result of those experiments, and finally decide, thinking every idea by ourselves, and coding everything by ourselves. That's what solo do. But when we team up, we can just share part of those jobs for other people. Like I'm writing code, and just after I done the code writing, I just share the code for other people, for my teammates, and he will just do the experiment and run the experiment, logging the result and analyze the results. So actually, it's much more happy to team up than solos when it comes to a competition. But if you're heading for grandmaster, solo goal is must. So that's very hard.
Just for the audience, I will be interviewing Philip later this week. He got a solo gold, so we will learn from him how does he keep doing that. Maybe Qishen will also get a solo gold again, and if he's not too angry, he will come again on the podcast.
How to say, because grandmasters are going to team up, so it's harder and harder for people to get in solo goal recently. But people like Philip or Guanshuo are still that the most famous person in the Kaggle ranking. He was number one for a very long time. Best fitting is also like solo, because when we are going to win the global first grandmaster place, solo is a better way, because when we win a solo goal, we can get a huge amount of point to make us climb the global ranking faster. So last year, I don't know whether you have looked at the Google landmark competition of last year. If you have looked at it, you will see Dieter win 2 solo golds in Google landmark competition, and he suddenly got 300,000 points, and he stand in the first place. Not this one. This is the 2020. I mean last year, 2021. 2021, yes. Dieter win 2 solo golds from Google Landmark 2021, and he suddenly got 300,000 points, and he's still global number one now, because the point is too much. So yes, people like then they are heading for number one, so they still want to go for solo. But as for me, I'm not that much like heading for number one or something like that. I'm just want to try new ideas in every competitions and try to learn new things from new competitions. So it's just okay. So I don't want to do that much hard work for heading number one. It's not not my goal. Yes. So I
4 months.
choose to team up. Yes.
I was going to say 4 months ago you were sixth. Now you are five. So in like roughly a year you will be number one.
No,
That's
no, no,
that's
no,
my
no.
that's my machine learning model.
It's very hard. People always, if people don't do solo first, solo goals is not enough for heading global number one. If you go for solo first 2 times in a very short period, you can go to global number one.
So you are saying solo first on a
Yes,
competition.
yes, solo first place in a competition 2 times in a very short period, like half years or 3 months, and you can go to global number one.
We know your secret strategy now.
It's
When
very
you are
hard.
doing that, we know you'll move up to one.
I'm never going to do that.
Okay. I, I will stop the joke there. I won't push the joke more. Um, Coming back to this competition, I would like to start by sharing the problem solution with problem statement with everyone, and you can correct me if I'm wrong.
Okay.
So the problem here is it's somewhat told in the name already. This is by UW-Madison lab, which is I think one of the leading labs in this research, and it's to segment tumors inside the stomach tract, I believe. Now, the challenge, as I understood, is these tumors move a little every day, and the radiologists who are treating these have to concentrate and move the X-ray to wherever the tumor is. So they have to like exactly pinpoint it. Which is why if I go to the data set, inside of train, you can see there are different cases. Let me zoom in. And there also you have different days because these are scans from different days when the radiologist have scanned again and they have pointed out where the tumor is. So you have to segment this. You have to figure out how to do this automatically so that we save time for the radiologists, for the doctors, to make it easier for them. Is this a correct explanation, Chishan?
Yeah. Every case day is a 3D instance, and every instance there are many scans. They are 2D images. So yes, 144 files means that there are 144 like we have 2 dimensions for 2D images, x and y dimension, and the z dimension is 144. Yes. So we can just train the models using 2D models, just the using original images, but we can construct it into 3D manner to use for using 3D CN as well. That is this competition.
For the audience, I'll point them to this notebook by, I believe it's Darian. This gives a really good explanation of the problem statement and matrix. So, once you saw the problem statement, what was your baseline? How did you approach this? Because I don't think you've participated in other 3D segmentation competitions, if I'm not wrong.
Yes. Actually, 3D image competition. I don't remember, but for last 2 years, I think this is the first one. Not very first, but I think it's really rare. But for the baselines, I use 2D models because it train much faster than 3D, and we have many knowledge in 2D CN models. So I choose 2D first for train our baseline. And how to say it does not work very well because you know that actually it's a 3D task. So if we just use 2D to train model, it won't perform as good as those models just using the 3D space knowledge to train the model. So yeah, the baseline wasn't works very well. So my teammate Bo Liu started to use Mon9 to deal with 3D images, 3D instance, and I started to try to train the 2.5D image models at very first. What I mean to 2.5D is that can you just show the data again? Show the data folder again. Yes. You can
One
see.
note, sorry, one note for the audience. Many people complained about this. I was one of the noobs.
Yeah.
So if you look at the image by default, it will show black because of the setting, and you have to change the CV2 setting because these are 16-bit images.
Yes. Actually, there are some information in the images, but the brightness got somehow weird, so we cannot see the. So every case state we have 144 slides or 80 slides. If we just use 2D to train those images using a single slice, we cannot get the adjacent slice like that see when we are training the number one image, we know that the information from number 2, number 3, or number 0 slice is always be useful for the number 1 images. But if we are just training 2D models, the knowledge of those slides, other slides, it just got lost. So the 2.5D model means that we input multiple slides into the model as multiple channel. So if you know very well of 2D CNN models, you know we train ImageNet using 3 channel, which is red, blue, green RGB. We have 3 channels for that. So in this case, we use like 3 slides as 3 channel to train the 2D model. And in this case, we still use 2D CNN model, but we introduce multiple slides information into the model at the same time. So we can get much better result than when we only use a single slide to train the model. Actually, how many slides we should use? This is a hyperparameter problem, and we try to turn it. And at last, we find that when we input 5 slides into the CNN model, 2D CNN model, and it can get the best results. And this is 2.5D method, and it introduces not only the current slice, but the adjacent slices information into the model. And this is 2.5D. And as for 3D models, we introduce every slices, all slices into the model at the same time. But at this time, we are not using 2D models, but we are using 3D models. And very first, we try to use Mon9 to train model, turning learning weight, batch size, and augmentation. Okay.
I wanted to interrupt you if it's okay.
Okay.
So you said, you just for the audience refresher here, normal images have length, width, and 3 channels, which are red, green, and blue. So you are saying for 2.5D, you are essentially replacing these with 5
Yes.
slices?
Yes.
So you have like 5 slices that you found through hyperparameter tuning, that this is the best, and you have like 5 images, 5 different days images that go into the model.
5 slides as 5 channels. Like if you go back to the data folder, can
Let
you
me switch screen sharing. Yes. I'm slow at that.
No. You can see there's slice 0001, 0002, 3, 4, 5. And when I want to change the slice 0003, I will use slice 0001 to 5
Okay.
to construct a 5-channel image. Because we don't have RGB here, we only have a grayscale image for each slice. So each slice we only have one channel actually. So we have 5 slices, so we have 5 channels. Okay, so we change the 2.5. Actually, it's 2D model, but because we are using 5 slices at the same time, so we call it 2.5D. Actually, it's 2D convolutional neural network. It's not 2.5D model, but it's 2D model using 2.5D data.
Okay. That makes sense.
Yes.
2D data with 5 channels. That explains it.
Yes.
Okay. And for 3D data, how did you construct that?
Yes, we can see that if you go back to the data folder, we can see that each case state we have 144 files, 144 slices or 80 slices or something like that. And the resolution of each slice may be 266 or 266 and 266. Yes. And if we stack every slice together in a single case state, we will get a tensor of shape of 266, and 144. It's a 3D tensor, right? And this time, the channel is 1 because every slice we only have the grayscale channel, not RGB, so it's only 1 channel. So the shape of a single 3D instance should be 266, 266, 144, and finally 1. Okay. If we are training 3D images with RGB formats, it should be X, Y, Z, 3.
Yeah.
But this time we only have 1 channel for the 3D images. And if we use batch size like 10, the 10 should be moved to the first dimension. So maybe 10, 266, 266, 144, 1. Well, actually, the final the second dimension should be the number of channels. So batch size, channel, XYZ. Yes, 10, 1, 266, 266, and 144. This is how we construct the 3D data. And then the next thing is how we design the 3D convolutional network. We first use MONAI, default ResNet, UNet. They have ResNet, UNet 3D model there.
It is there somewhere. You can find it on the website.
3D segmentation example, I think that's it. Yes. Maybe the first one or the second one is good. Yes. The data set is quite similar to the data set of this competition as well, but it's brain. Okay. So we have some default models from MONAI, ResNet UNet. They have ResNet UNet 3D convolutional neural net model there, and we use it to train our constructed 3D data sets at very first. So we start to turn every hyperparameter like batch size, learning rate, and augmentation, number of epoch or something like that, and we find that Another problem, the difference between 2D to 3D in this computation is that the number of training sample is quite different. If we train the model using 2D model, we have 144 images for each case days, and we have near 40,000 images in total in the training data. But after we construct the 2D images into 3D, we only have near 3,000 training sample left, because we construct 100 images, 100 training sample into one training sample. So we have only near 300 training sample left. So for image task, 300 training sample is only a very little number. It's really easy to be overfitting, or the models just can't be trained very well. This is another challenge as well. So MON9 give us very good experience when we start to learn 3D image segmentation, and but we also find the problem of MON9 because they don't have other backbones for 3D segmentation. They only have ResNet, because I have just said before, because when we compare 2D and 3D, the 3D models absolutely have much larger number of parameters, so the model got very large. Even it's just like ResNet 50 UNet. We all know that in 2D, ResNet 50 is not a big model. It's just a small or medium model. It's just but when it comes to 3D, a ResNet 50 UNet, it's very large. How to say, the file size is, if I don't remember, if my memory is correct, it should be near 1 gigabyte large, a 3D ResNet 50. So it suddenly.
Sorry, I was going to say for the audience, and you said this earlier, but because of 3D, we increase the parameters so much, and it exponentially increases the size.
Yes. Yeah, so the ResNet 50 suddenly become a very large model. So MON9 just choose not to expand this into other backbone. I think it's one of the reasons. I don't know actually. So they only have ResNet for 3D segmentation. But actually, we who are doing competition, we always want to try other backbones or other decoders or something like that to see what's the difference in the performance. Like I want to use EfficientNet, 3D EfficientNet. So in this case, I have to write by myself, and actually I do that. I did that from learning TIMM and learning MON9, and actually try to convert the 2D backbone in TIMM to 3D manner and use it as encoder to train the 3D dataset.
You said this in the comments as well. I think someone had asked this question where you said you just rewrote different modules.
Yes.
So
Yes, actually, the model, the 2D convolutional neural network model was constructed from many modules, like convolutional module, pooling module, and the normalization module, or something like that. And some of it is restricted to 2D. Some of it is just no longer 2D or 3D, like sigmoids. You can apply it both 3D and 2D, and it's just okay. But some of those modules can only be applied to 2D, and I just check it and replace it by a 3D module, and so that it can be input by a 3D input. So I wrote some code to convert every 2D related module in the 3D manner into 3D module, so that it can just be transformed into a 3D model. It's a very simple idea, and it's not very hard work, and we can just use the well-designed architecture in 2D and just applied it to 3D. Yes.
So, how did you make the pre-trained weights work with this?
Sorry?
How did you make the pre-trained weights work with this?
Make what?
The ImageNet weights work with 3D modules. So as you
Okay.
converted,
Yes. That's another challenge I just mentioned before. So we know that the 2D convolutional kernel is like 3x3 size, and the 3D convolutional kernel size is maybe 3x3x3. It has one dimension more. So I just simply copy the ImageNet pretrain weight 3 times and stuck them together to make the 3x3 array into 3x3x3 array. Yes, that's the way how I transfer the 2D pre-trained weight into 3D. It's not very good solution, but I think it's better than train from the scratch. Actually, I didn't do the experiment yet, but I think so. I don't know.
okay. Thanks for sharing that. I will now share my screen and just go through your solution in case you want to highlight anything. Although you have given most of the background, so
Yeah.
anything you want to highlight from your final solution?
Yes. As for the 2.5D models, actually there is another trick as well. Because when we look at the data folder, we know that the data folder is constructed by slice, right? Every slice is a training sample, and we just defined it as the height and the width of a slide as x and y.
Mhm.
And we can know that the z-axis, the z dimensions, is 1, because xy is the height and width of a slice. But actually, after construct all slice into a single instance, like we find that actually we can cut the 3D instance from different dimension. We can cut it from x and y, not only z. We can cut it from x and y to build two other type of 2.5D datasets. And we can train 2.5D models using those datasets as well. Actually, the model trained on other two 2.5D datasets are not performance are not as good as the original X datasets, but we find that when we do the ensemble using X, Y, Z, 3 types of those 2.5D datasets, it works very well. Yes, that's another trick of our solution.
Okay. Um, you also mentioned in your write-up that for a long time you had lost hope for gold, but you kept trying, and towards the end you found the secret of ensembling and realized it worked better.
Yes,
What
yes,
I
because
was going, sorry, I was going to ask, why did you not give up? Like, I lose motivation really fast. I see people like Chishin and Bo on the leaderboard, and I think I can't go up that high on the leaderboard. I will give up. These guys will win a gold. I can't do it. Why did you not give up?
well, how to say? Because for competition, it depends on what you want to achieve in a competition.
Hmm.
For most of the competition, actually, before the end, I don't know whether I can get a gold medal or not. For most of the case, for at least 80% of the case, I don't know whether I can get gold medal or not before it ends. Um, what we can do, or what we only can do, is that we try our best to learn new things, to try new ideas, to train the model, turn in the parameters, and design the final ensemble and submit it. So I think if I can, after the competition ends, if I cannot get a goal, I can compare my solution to other goal solution to see what's the difference between them, so that I can learn a lot of things. If I can get a gold medal, I will know that my solution is not that bad. Actually, it is very good.
Hmm.
um, and I can learn many new things from other solutions as well. So if your main goal is to get a gold medal, you will get many pressure, because for most of the cases you cannot get to the public leaderboard gold zone. There are so many people overfitting the public leaderboard. So actually they are going to shake down, but before the competition ends, you never know that. um, so if actually, I suggest everyone to join the competition, not to the goal should not be set to I want to have a gold medal or something like that. You should The goal of joining the competition should be learning new things. You can learn as much as you can, and in this case, you won't get that much pressure, because no wonder you get gold medal or silver or bronze, or even 300 also rankings. You just can compare your solution to those golden solution to see what's the difference, and you can learn many new things. That's just very good.
That's a great suggestion. I think with time it's you get that wisdom. But as someone who's new and who's like trying to trying to get to that glowing gold, it's hard to focus on learning and easier to overfit even for the public leaderboard.
Yeah. But actually, after you learn many things from many competition, you will have your gold medal sooner or later. It's just not in a hurry, right?
Okay, I will remember that while I'm trying for the 3 solo goals that I need to team up with you. uh, I will try not to bring that joke again. Coming back to your solution, so we've covered 2.5D models, we've covered 3D models. Um, Anything else you want to highlight before we move on?
No. That's
Okay.
all.
And again, for the audience, I'm just going through the interesting bits. You can find the link in the description to the write up. Do read it, it summarizes everything really nicely. Um, I think one thing that remains is post processing. So you say you discarded images that had a predicted area less than 50 pixels.
Yes, because we find that there are some noise in the predicted mask. And actually, when we try to analyze the training data, we find that there are somewhere it should have a mask, but it does not, because the host mentioned the reason, but actually in this case the model are not able to learn that, because there are actually a thing there, but we should not predict mask on it if we want to get higher score. It's a very hard challenge for a model to learn it by itself. But after the competition end, we find that people actually can learn it using a classification model. The first place and the second place use classification model as well, I think, and they just use it very well. And it's really the functionality of the classification model is kind of similar to our post-processing, because they are doing the same thing, is to remove the mask from those noisy label. How to say? Yeah, it's kind of it. We are removing. They are using classification model to remove some mask from the images. We are using post-processing to remove some mask from the image to get higher score. But absolutely, model is doing better than post-processing. Yeah.
So in a way, you're removing false positives.
Yes.
Okay. Anything else you wanted to highlight in your solution?
I think that's all. We actually find that the ensemble of three types of 2.5D and 3D model works very well. That's it. Actually, our single model are not performed that good. Yes. That you can see, if you have looked at the discussion before the competition ends, you can see some people declare their single fold model can reach 0.882 or 0.883 public leaderboard, but actually our model can only go to 0.875 or so. So at that point, we think we are just losing the confidence to get the gold medal. But finally, we find that the ensemble of those models works very well, and yes, it's a kind of lucky. Yes.
How much time do you leave while competing for like final submission preparation? So I assume you found this during the last few days. Do you like always leave time for figuring out, or hill climbing, figuring out best ensembles towards the end?
Yes, it depends on the size of training set, I think. If like this time, the training set, we estimated our training time for a single model is maybe 1 day. So we will have maybe 10 models at final ensemble. So we will have 10 days for training those final models. And the time before, we were just trying to figure out the secrets in the data set, or thinking new ideas, trying new things, or something like that. So we have a very first estimation of the final training time, and we just left that time as training the final model. But it depends on the size of training data. If it comes to Google Landmark, if you know that it has 4 millions of training images. 4 millions training images. So we estimate that we train a single model, it takes a week. And we will have maybe five final model in final ensemble. So we should have a month or even more to train the final model. So yeah, it depends on the training data.
Okay, thanks for sharing that. Um, I think that's the last thing I wanted to discuss. Anything else you want to highlight before we wrap up?
I'm okay.
Okay. Let me quickly point out audience to your Kaggle profile, where they can find your LinkedIn profile link. I hope Chishan you joined Twitter because there's a strong, strong Kaggle community on Twitter as well. Uh, I will put this link in the chat and highlight it. Please find Chishan on Kaggle, connect with him on LinkedIn. I think those are the two platforms where he's active. If he's not too annoyed, I will try to bring him in again for an interview for future goals that he will win. Uh, Thanks so much again, Chishan, for sharing your solution and also sharing your journey. And also, congrats on the new solo gold and moving to top 5.
Yeah, thank you very much. I'm very happy to share my ideas, my thinking here as well. Thank you very much.
Okay. Thanks everyone for joining as well and also for sending in your questions in the chat. I was trying to read through them. That's why you saw me looking here. But thank you for watching, everyone. I'll end the live stream.
Bye.